Alrighty, so now another thing that really confuses people just in general with exponents is when they have negative bases. And I think a lot of people forget that the negative sign is attributed when it's inside a parentheses and then there's a power being raised to it. The negative sign has to be attributed to the base and not to the outcome of it. So I'm gonna show you what I mean. So if I'm gonna do a real simple example. If I have negative 2 to the 4th power, this is not the same as negative 2 to the 4th power the way you write it over here on the right. Okay, on the left, what this means is I have negative 2 times negative 2 times negative 2 times negative 2, right? And that equals 16, okay? It's because negative times negative is positive, and then a negative times negative over here is a positive, and positive times positive is 16. And then hopefully you can figure out that 2 times itself 4 times gives you, that's where the 16 comes from. All right, whereas this problem over here, the way I would evaluate this is I would do this first. So I'd have negative, and then whatever 2 times 2 times 2 times 2 is, which is 16. So you wind up with negative 16. So that's why 16 is not equal to negative 16 ever in any universe, right? So when we work with bases that have a negative with them, you have to remember that you're applying that to your evaluation of it, right? So when you're multiplying it out, you have to factor in how do those negative signs work, all right? So we're gonna try and make this as user-friendly as possible here. So let's do this first one. So the first thing I know is that if I take this, right, and it's negative, it means it's 1 over negative 3 to the 4th power. But I hope you're looking at that and saying, well, that's what he told us not to do. And you're right, this is what I told you not to do. It should look like this, right? It should stay like this because this negative sign is with the number. That's not on the outside of it saying, oh, you're going to apply that after you evaluate it. It's actually with the number right now. So what this means now is it means 1 over negative 3 times negative 3 times negative 3 times negative 3. And I know 3 to the 4th is 81, but I also know that negative times negative is positive, and then you got 2 more, and that makes positive, and then all your negatives are used up, so you have 1 over 81. And a good rule of thumb is, well, actually, let's do this next one, and then I'll explain it, because it'll have some context then. So this one, let's do the same thing. So we have 1 over negative 5 to the 3rd power, which is 1 over negative 5 times negative 5 times negative 5. Now, on this problem, right, when I multiply negative 5 and negative 5, I'm going to get positive 25. And then when I multiply 25 by negative 5, I'm going to get negative 125. So I have 1 over negative 125. And the rule that I like to use that I think is pretty simple because it makes sense to me, and it might not make sense to you, but hopefully it does, is when I'm raising an exponent to something, whether it's positive or negative, it doesn't matter. When I'm raising an exponent to a base that has a negative sign with it, if my exponent is even, then that means my value is going to be positive. If my exponent is odd, and this is only dealing with negative bases, all right? This is only dealing with negative bases. If my exponent is odd, then I'm going to have a negative value because even numbers of negative signs will always cancel each other out, right? And so that's why this one, which has an odd number, is negative, and this one, which has an even number, is positive. All right, so that's a little trick that I like to use. All right, so now let's try this one. All right, so we're going to do the same thing, even though it's got a fraction. We're going to flip this thing around, okay? So we're going to go negative 3 over 2. The negative sign just kind of goes along for the ride. It doesn't matter where it belongs. Thirds, right? Remember, that's what you do with fractions. You invert the fraction, you flip it, you use the reciprocal, however you want to think about it. And then now that's to the 3rd power. So what we have, I think it's easier for these to just write it out like this, like negative 3/2 times negative 3/2 times negative 3/2. So we have a negative times a negative, which is this. These two will make a positive, and then you have a positive times a negative. So whatever my result is, it's going to be negative. All right. Then you have 3 times 3 times 3, which is 27, and 2 times 2 times 2, which is 8. And you get negative 27/8. All right. Again, hope this is somewhat useful to you, and that it's helping you.